Hello, Math 112 fans. Some of you asked you wanted some more practice. So I'm going to do, this is part one. We're going to talk about derivative skills. Um, what I have over here on the right is from my summary page. There's honestly only three derivative rules: the power rule, the exponential rule, and the log rule. Everything else is combining those: product, quotient, or chain. If it helps, you can break up the chain rule into three types. But once you understand the chain rule, you don't really have to think about it as separately. Your main job, the main challenge we've kind of been dealing with for a while, is rewriting things so that you can use your calculus skills. And so we can quickly do several problems here. All of these are from my recent exams, from the first page of recent exams. So you have to be able to rewrite this: -3 halves. So if you don't know that, I have some old reviews you can go back into. Nothing else needs to be rewritten. That's sort of step zero in every problem we're dealing with this term. Then we're ready to do the calculus. So I'm going to move this over so that I have a little bit of space. And so we're ready to do the derivative. Let's go. So what do we have? We have two terms. So the way you break this down is this goes back to the beginning of the term, but you have a plus right here. You have a coefficient. You have a coefficient. Those are the sum and coefficient rules. I don't usually list those in the rules because at this point we need to know them well. The rest is bringing down the power and then subtracting 1. So you're going to have a -3 halves, x to the -3 halves minus 1. So it's -5 halves, plus, and then you do however you do the log. So you use that log rule. That's actually the chain rule. So the derivative of the log. So again, the rules you're using are really these three rules. Maybe I'll say them in a different way. We have blah to the n. We have log of blah. And this is really how you think about the three situations you can encounter are those. So the first thing we had was blah to the n, but n was -3 halves. Now we have log of blah. And the rule is 1 over blah. That's the rule for log, times the derivative of the inside. That's what you should be writing. The coefficient 10 just comes along for the ride, times 1 over x to the 4th plus 1 times 4x to the 3rd. That's it. Now, if I was doing this, I would clean it up. I don't expect that on the test, as we talked about in class. This would be 40x to the 3rd over x to the 4th plus 1. Okay, let's keep going. What do we have here? We have a big mess. It can't be separated by a plus or minus, but it's a quotient rule. We did this one in class. Denominator times derivative of the numerator minus numerator derivative of the denominator all over the denominator squared. Denominator. And you can fill in the whole thing kind of without thinking. And then you have minus, and then we're going to have the numerator. And then you come back and say, I have two smaller jobs to do. The derivative of the denominator is 4. The derivative of the numerator is another one of these logs, a log of blah. So it's going to be the derivative of the inside is going to be 12. So if I was going to do it, I would just write 12 over 12x plus 3. So yet another example of this. And you did a lot of that back in chapter 11. Okay, what do we get here? It asks for the marginal cost, but truly this is not an applied problem. It's just take the derivative. What's the derivative of total cost? The derivative of 50 is 0. And then we have product, quotient, or chain. Product rule. First, second. So we're going to do first times the derivative of the second plus the derivative of the first times the second. So at this point, we have played these games a lot. You've probably done a couple hundred derivatives. So at this point, we've got to start internalizing if we're not there yet. So what do I do with this term? A calculus student would write it as 1/2 times x. So this is going to be 1/2 times x times the derivative of the inside, which is a half. Plus the derivative of the first is 24x times e to the x over 2. All right, that's nice. What do we have here on this third one? Let's scroll up a little bit. Everything is trapped inside a 10th power. So this is a blah to the 10. And how do you take the derivative of a blah to the 10? The 10 comes down and it becomes a 9. Step 1 done. The inside stays the same. It's the log of t cubed plus 1. And then we restart. We basically say now all we have left to do is the derivative of this. Whatever the derivative of that is, we're going to put in this spot. Well, that's a log of blah. So you're right. 1 over t cubed plus 1. So that takes care of that. And now we need the derivative of the inside. Times 3t squared. 3t squared. I would just write it right there. Done. That's y prime. What about this one? How would a calculus student write this? They would write 1/2. They would write plus 3x. And there's a couple little things to do here. They'd write 5/6 e to the negative x to the 1/2. The negative is coming about because it's on the bottom. The 1/2 is from the square root. So f prime. Derivative of the first is 0. Derivative of the second is 3. The derivative of the third is 5/6 e. This is an e to the blah question, this one here. And so we have, I'll pull this up in case I was marking something. So we have one of these situations. So it's x to the 1/2 times the derivative of the inside, which is negative 1/2 x to the negative 1/2. So that's it. You can find nothing on our test will be any more complicated than anything we just did there. Those need to become routine. The main place to practice would be chapter 11. All right, hope that helps.